Welcome to PrimeStar Automotive. This is lesson 007. If you are new and a learner and want to digest more of our lessons and you haven't watched the other video series from 001 to 006, I recommend you go back there and watch. Only then it will make more sense in your learning stage. Anyhow, whether you are an automotive student, an apprentice, a technician, or an enthusiast, you're in the right place. Let's learn together. Today's lesson, we are going to learn most of the major suspension parts and components, their location, and why they are there. What is the suspension system? The suspension system connects a vehicle to its wheels, manages handling, and absorbs road impacts. It consists of structural, dampening, and pivoting components working together. Now let's proceed to the workshop and learn to identify the suspension system by first identifying its components and parts. Now that we are in the workshop, let's put our vehicle to the lifter or the hoist safely. Important tip: in lifting the vehicle, there are safety rules and precautions you need to be aware, apply, and maintain while in a workshop or working with a vehicle. We will talk safety and precautions later in our future lessons. Now we are going to start locating the component one by one. To do that, it is best that we see it from underneath of the vehicle to learn the locations and connection. Now you are looking at the underneath of the vehicle. As you can see, the descriptions of the suspension is what you are seeing when you see the underneath of the vehicle. And the description says the suspension system connects a vehicle to its wheels, manages the handling, and absorbs the road impact. It consists of structural, dampening, and pivoting components working together. And that is exactly just that. It sounds simple, but it is not. But I will make it easier for you to understand that even if you are not a technical person, at the end of the lesson, you will learn something. For the sake of learning, I will ask you to hold the underneath image of the vehicle that you have just seen underneath while you are under the hoist. What I will do is bring down the vehicle from the hoist. To continue our learning phase, I will remove the body of the vehicle to expose the suspension components more elaborately. For the sake of learning, you are now looking at the full front and rear suspension, including chassis assembly. It is better this way. This is what it would look like if you are looking at the suspension of the vehicle. This is the picture that is on every mechanic's mind when diagnosing a suspension problem. We will talk about it on different lessons later as we progress in the course. To give you more perspective and a better way of learning, let us separate the front suspension from the rear suspension. The front suspension is a group of parts that connects the front wheels to the vehicle. Its main job is to support the weight of the vehicle, absorb bumps in the road, keep the tires in contact with the road surface, and help the driver steer safely. As you drive, the front suspension moves up and down to absorb the road bumps and uneven surfaces. This helps provide a smoother, more comfortable ride while improving vehicle stability and control. Note that all of the suspension components work together to help keep the vehicle safe, comfortable, and easy to drive. Now it's time to name the parts and components of front suspension. I want you to study each component, locations, and connections, because throughout the course of this lesson, we will be coming back to this image. Note that this is a typical SUV and four-wheel drive vehicle front suspension. It may vary slightly, depends on models and make. Let us keep going with our learning phase. At this stage, it is very important that you can identify the component, recognize their locations, and understand their functions. Because when we discuss them in greater details in our future lessons, it will make more sense. Alright, I will let you spend time on these photos and recognize them. Before we continue the lesson on suspension, I want you to take a look at these three photos especially. When the pogo stick hits the ground, the spring compresses. As the spring expands again, it throws the rider back up to the air. It would keep bouncing up and down over and over. And the rider would have very little control because the spring keeps releasing the energy it is stored. In our younger days, we enjoy it. Everyone does the pogo stick in the younger days, unless someone that you don't know. But now you know. But when we get to the middle age, I think it's no longer that fun as a younger. How much more when we really get older? That would be a struggle. Now think of a car. The suspension springs do exactly the same thing as a pogo stick. They compresses when the wheel hits the bump and then expand again. Without something to control that movement, the vehicle would continue bouncing after every bump in the road. This is where dampening comes in. The suspension dampening system controls the movement of your vehicle springs, keep your tires on the road, and ensuring a smooth ride. Without dampening, your car would bounce uncontrollably like a pogo stick after every bump. Now let's focus first on core dampening components. They are the struts, coil springs, shock absorbers, leaf springs, torsion bars. Shock absorbers dampen the bounce of the vehicle springs by converting kinetic energy into heat. And take note, we will study shock absorbers in more details in future lessons. Struts. Structural components combining a shock absorber and a coil spring into one single unit. Please refer to the image of what the strut assembly looks like, because we are going to use this in our future lessons. Coil springs. The coil springs are heavy steel springs that compress and expand to absorb major road impacts. The coil spring and shock absorber makes into struts assembly, but each performing different function. We will discuss this into greater details in our future lessons. Leaf spring suspension. A layered steel plate used mostly on trucks to support heavy loads. A leaf spring is a type of suspension spring that made from several thin strips of spring steel, called leaves, stacked together and clamped into one assembly. Its purpose is to support the vehicle's weight, absorb bumps on the roads, and help keep the tires in contact with the road surface. Leaf springs are commonly mounted between vehicle's chassis and rear axle. In most vehicles, one leaf spring is fitted on each side of the rear suspension. In addition, leaf springs are commonly found on pickup trucks, utility vehicles, vans, heavy-duty trucks, some trailers, some older four-wheel drives as well. I need you to take a good look at the leaf springs because we are going to discuss this in greater details in our future lessons. Torsion bars. The torsion bars are steel bars that twist under load to provide springing action. Note that torsion bars is mostly found on four-wheel drive vehicles, SUVs, pickup trucks, and utility vehicles. A torsion bar is a long, solid steel bar that acts like a suspension spring that works by twisting instead of compressing. It supports the vehicle, absorbs bumps, and helps provide smooth ride and stable ride. The torsion bars twist under load to provide spring action. At closer look, this is what the torsion bar looks like. Torsion bars usually mounted under the front of the vehicle, running lengthways along the chassis. One end is connected to the lower control arm, while the other end is securely attached to the chassis through an adjustment mount. We will go into great details on this on our future lessons. Now, let's look at the structural and linkage components of the suspension system. Think of this as the framework of a suspension. Structural components provide the strength, linkage components provide the movement. Together, they keep the suspension strong, connected, and stable. Structural components provide the strength needed to support the vehicle, while linkage components connect the suspension together and allow it to move. Without these components, the spring, the shock absorbers, the other suspension parts would have nothing to attach to. They also help keep the wheels securely connected, correctly aligned, and moving safely as the vehicle travels over bumps and uneven roads. Some of the main structural components include the chassis or frame, the subframe, the suspension crossmember, and the axle housing and the steering knuckle. At this stage, it's only important to recognize these components and understand their basic purpose. In our future lessons, we will explore more on every one of it in great details, including how it works, how it's inspected, and the common faults you may encounter. Now, let's go back to this front suspension image again and focus on the structural and linkage components. Let's bring the parts into focus and for the sake of learning this lesson, let's look at a different angle. Now we are looking at the control arms. The control arms connects the steering knuckle to the vehicle's chassis or subframe. Their job is to keep the wheel in the correct position while allowing the suspension to move up and down as the vehicle travels over bumps and uneven roads. They also help support the suspension and keep the wheels properly aligned. making the vehicle safer and easier to control. You will commonly find control arms on the front suspension of many passenger cars. On some SUVs and four-wheel drives, especially those fitted with an independent rear suspension or IRS, you'll also find control arms on the rear suspension. At this stage, it's only important to recognize what control arms look like and where they are located and to understand their basic purpose. In our future lessons, we will explore the different types of control arms, how they work, how to inspect them, and the common faults that we always encounter in the workshop. Here is the control arm in a closer look of the components, although it still differs a bit depending on the manufacturer's brand and design. This is called the steering knuckle. On many SUVs and four-wheel drives, it is also commonly referred to as the spindle. The steering knuckle is the component where the wheel hub and brake assembly are mounted. It also connects the steering and the suspension component together. Think of it as the backbone of the wheel assembly. Many important components are attached to it, allowing the wheel assembly to work as one complete unit. Its job is to support the wheel assembly while allowing the wheel to rotate as the vehicle moves forward, reverse, and turn left or right when the driver steers. You'll commonly find this type of steering knuckle on vehicles fitted with an independent front suspension. At this stage, it's only important to recognize what the steering knuckle looks like, where it's located, and understand its basic purpose. In our future lessons, we'll explore the independent front suspension system and take a much closer look at how the steering knuckle or spindle works together with the other suspension and steering components. Introducing the trailing arms. Trailing arms are usually found in the rear suspension of many passenger cars, SUVs, and four-wheel drives. They are mounted between the rear axle or wheel hub and the vehicle's chassis or body. A trailing arm connects the wheel or axle of the vehicle's structure, keeping it correctly positioned while allowing the suspension to move up and down. In future lessons, we'll explore the trailing arms in greater details, including its construction, mounting points, operations, inspection, common faults, and replacement procedures. Looking more closely, notice how the trailing arms run lengthways between the chassis and the rear axle. This mounting direction is why they are called trailing arms. The axle and the wheels are supported behind their forward mounting points. The arrows now identify the trailing arms more clearly. Each arm is attached to the chassis at one end and to the rear axle assembly at the other end. These mounting points allow the axle to move with suspension while preventing uncontrolled forward and backward movement. We will examine their construction, mounting points, and other operations in greater details in future lessons. Now let's move to the trailing arms to lateral links. Lateral links are commonly found in the independent rear suspension system, also known as IRS. They connect its rear wheel hub or hub carrier to the vehicle's rear subframe. Their main purpose is to keep the wheel correctly positioned while still allowing it to move up and down independently. In this illustration, the lateral links are highlighted in blue. Notice that these links are extended across the vehicles, from the subframe towards each wheel assembly. That direction helps us recognize the difference. Trailing arms generally run lengthways along the vehicle, while lateral links generally extend sideways across the vehicles. For now, remember their appearance, locations and associations with the independent rear suspension. We will explore the different lateral links arrangement and their operation in future lessons. This closer view confirms where the lateral links are fitted. Notice how each link extends from the rear subframe towards the wheel hub or hub carrier. Because this is an independent rear suspension, each wheel uses its own links and can move separately from the wheel on the opposite side. This is what a lateral link may look like when it is removed from the vehicle. It is normally a strong metal link with a mounting bush at each end. The exact shape and length will vary between vehicles, but its basic purpose remains the same: to locate and control the wheel laterally. Now compare that with a panhard rod. A panhard rod is normally used with a solid rear axle. It runs across the vehicle, connecting the axle housing to the chassis, and helps prevent the complete axle assembly from moving too far from side to side. Here is the key difference. A panhard rod controls the sideways position of one complete solid axle. Lateral links are mainly used with independent suspension and control the position of each individual wheel or hub carrier. They may look similar, but they are used in different suspension arrangement. Panhard rod versus lateral link. Visual comparison. Looking at these two systems side by side makes the difference easier to recognize. On the left, one panhard rod locates the complete solid axle. On the other right, several lateral links locate the individual wheel assemblies. For this lesson, remember the system in which each component is normally used. Now let us identify the sway bar, which is also known as the anti-roll bar or stabilizer bar. It extends across the vehicle and connects the movement of the left and right sides of suspension. Its main purpose is to reduce excessive body roll when the vehicle is cornering. Observe as the image moves closer. Follow the shape of the sway bar across the front suspension. It is usually a long, shaped steel bar mounted to the vehicle through rubber bushes, with each end connected to the suspension. Here is the sway bar in closer view. Notice the long center section and the bends that allow it to fit around the surrounding suspension and steering components. These bends will vary depending on the vehicle design. This is what a typical sway bar looks like when you remove it. The center section mounts to the body, chassis or subframe through the rubber bushes. The ends connect to the suspension, usually through stabilizer links or, on some designs, directly to the control arms. Returning to the complete suspension, notice again how the sway bar reaches from one side to the other. That across the vehicle position is one of the easiest ways to identify the underneath from the vehicle. At this point, you may be wondering, what do many of the suspensions and steering components actually mount onto? This large structural member is called the subframe. It provides strong mounting points while allowing major assemblies to be built and installed as one unit. At the front of the vehicle, the subframe may support components such as the control arms, steering gear, and on many vehicles, part of the engine or drivetrain. It is securely attached to the vehicle body or chassis and forms a strong foundation for the front suspension. This is an example of a rear subframe. It supports and locates the independent rear suspension components, and on many rear-wheel drive or all-wheel drive vehicles, it may also carry the rear differential. Think of it as the structural foundation of the rear suspension assembly. Why pivot and connections matter. Suspension components cannot perform their job unless they are connected while still being able to move. Ball joints and rubber bushes provide control pivot points. Bolts, stud, and mounting brackets hold the parts securely together. These connections allow suspension movement while maintaining wheel position and vehicle control. Now let us identify the ball joints. In this double wishbone suspension, ball joints connect the steering knuckle to the upper and lower control arms. They allow the suspension to move up and down while also allowing the steering knuckle to turn. Note, we will discuss double wishbone suspension in greater details in our future lessons. The image moves towards the lower ball joint. Look for the rounded joint housing positioned between the lower control arm and the steering knuckle. Here is the lower ball joint in close-up. The tapered stud is secured to the steering knuckle, while the joint housing is attached to the control arm. Inside the housing, the ball and socket arrangement allows movement in several directions. This is what one type of ball joint looks like when removed from the vehicle. Designs vary, some are bolted, some are pressed into the control arm, and others are supplied as part of a control arm assembly. Depending on the suspension design, a ball joint may also carry part of the vehicle load. Rubber bushes, also called bushings, are flexible connectors fitted at many suspension mounting points. They allow a controlled amount of movement while cushioning metal components from vibration, road shock, and noise. You will commonly find them in control arms, trailing arms, lateral links, sway bars, and subframes. The sway bar cannot work with the suspension unless its ends are connected. That connection is commonly provided by a stabiliser link, also known as a sway bar link. One end attaches to the sway bar and the other attaches to the strut or control arm or steering knuckle, depending on the suspension design. In this full suspension view, the stabiliser link is a relatively small component near the wheel assembly. Although small, it transfers suspension movement into the sway bar so the left and right sides can work together during cornering. The closer view shows the stabiliser link and its two connecting points. This design uses a short vertical link with a joint or bush at each end. This is a stabiliser link on its own. Its length and end fittings vary between vehicles, but it will always be found forming the connection between the sway bar and a moving suspension component. And let us identify the subframe bushes. These large rubber bushes are fitted at the main points where the subframe attaches to the vehicle body. They hold the subframe securely while helping isolate vibration, road shock, and noise. Looking at the complete subframe, the bushes are positioned around its outer mounting points. These locations allow the entire subframe assembly to be bolted to the vehicle. The image now focuses on two of those subframe mounting points. Notice how the rubber bush is built into the end of the subframe rather than fitted as a separate, visible linkage. The next pair of mounting points follows the same arrangement. Together, the bushes support and locate the subframe while allowing only a small and controlled amount of movement. These are examples of subframe bushes removed from the assembly. Their size and shape vary, but they normally have a rubber body with a metal center sleeve or outer shell, so the mounting bolt can secure the subframe correctly. Now let us identify the tie rods. Tie rods connect the steering rack or steering gearbox to the steering knuckles. When the driver turns the steering wheel, the tie rod pushes or pulls the steering knuckles, so the front wheels turn in the required direction. The image now moves towards one side of the steering system. Follow the steering rack outwards towards the wheels, and you will find the tie rod assembly between the rack and the steering knuckle. In this closer view, the flexible bellows boot hovers the inner rack and joint. Extending outwards from it is the tie rod, which continues towards the outer tie rod end at the steering knuckle. This leveled view shows the complete connection more clearly. The steering rack, the inner tie rod or rack end, the tie rod, and the outer tie rod end connected to the steering knuckle. We will study adjustment, alignment, and inspection in later lessons. Now, look at one of the busiest areas underneath a vehicle, the wheel assembly interface. Around each wheel, the suspension supports and locates the wheels, the steering changes its direction, the brakes slow it down, and on the driven wheel, the drivetrain delivers power. As the view moves closer, concentrate on the areas besides the front wheels. This is where several separate systems meet and must work together without interfering with one another. In this closer view, you can see the suspension link, steering connections, brake and drive shafts gathered around the wheel assemblies. For now, recognize this as the shared connection area between these major vehicle systems. At the center of the wheel assembly is the wheel hub. The wheel is mounted to the hub by the wheel studs, while the wheel bearing inside the hub allows the wheel to rotate smoothly. Depending on the vehicle's suspension design, the hub assembly is mounted to a steering knuckle, rear knuckle, hub bearing, upright or axle housing. Now move your attention to the top of the front strut assemblies. The upper strut mounts attach the strut securely to the vehicle body and provide the upper mounting point for the complete assembly. The image now moves towards the top of one of strut. This is where the strut passes upward into the vehicle body or strut tower. Here is the upper strut mount in close-up. On many front MacPherson strut systems, the mount includes rubber insulation and a bearing so the strut can rotate smoothly as the wheels are steered. We will dive into this in great details when we tackle the MacPherson strut suspension system on our future lessons. These labeled illustrations identifies the main features of a typical strut front mount. The mounting studs, hub plate, rubber isolator, and center bearing. The exact construction varies, but its location remains at the top of the strut assembly. We're going to dig further regarding the construction of strut mount on our future lessons. Here we can compare the mount by itself with the same component installed in the strut tower. This comparison helps connect the part you may see on a workbench when its actual location in the vehicle. Putting these components together gives us the MacPherson strut suspension. It combines the strut, coil spring, upper mount, steering knuckle, and related components into one compact front suspension arrangement. At this stage, identify the assembly and its major parts. Its detailed operation will be covered later in our future lessons. Now let us move to the rear of the vehicle. Rear suspension designs vary considerably, but they all support the rear of the vehicle, absorb road impacts, and keep the rear wheels controlled. This example shows an independent rear suspension with lateral links. This second example uses separate coil springs and shock absorbers, with a rear differential and drive shafts between the wheels. It reminds us that the layout may change from vehicle to vehicle, even though the basic suspension jobs remains the same. First, locate the rear shock absorbers. In this design, each shock absorber is mounted separately from the coil spring. The shock absorber controls unwanted suspension movement and helps prevent the rear wheel from continuing to bounce after a bump. The closer view shows one shock absorber on each side of the rear suspension. Follow each unit from its lower suspension mounting point up towards its upper mounting point on the vehicle body. Next are the rear coil springs. These springs support the rear portion of the vehicle and compress and extend as the wheel travels over bumps and dips. As the image moves closer, notice that one coil spring is fitted on each side. In this arrangement, the spring sits separately from the shock absorber. This closer view makes the shape and location of the coil spring easier to recognize. Each spring sits between the suspension member and the vehicle body or spring seat, depending on the design, based on manufacturers and brand. The top of its rear shock absorber is the upper shock mount. This is the point where the shock absorber is secured to the vehicle body or chassis. The image now moves towards the top of both shock absorbers. Follow its cylindrical body upward until you reach the upper mounting bush, stud or bracket. Here are the upper mounting points in close-up. These mounts secure the shock absorber while using rubber bushes or insulators to reduce noise and vibrations entering the vehicle body. Now, let's identify the rear sway bar and its links. Like the front sway bar, the rear bar extends across the vehicle and connects the movement of the left and right sides of the rear suspension to help reduce body roll during cornering. The image now moves towards the lower rear suspension where the sway bar is fitted. Look for the shaped bar running from one side of the vehicle to the other. As the view moves closer, follow the sway bar towards the wheel area. Near each end, a stabiliser link connects the bar to a moving suspension component. This wider close-up shows the rear sway bar crossing the suspension beneath the differential. The bar is supported by mounting bushes while its end connects to the suspension through the links. Notice the bar's position across the vehicle and the link near its outer ends. That combination, a bar across the suspension with a link on each side, is the main visual pattern to remember. This labeled view confirms the three parts: the rear sway bar across the center, and one sway bar link on each other. Together, they help control body roll at the rear of the vehicle. This is a good picture image showing a sway bar links working together with the rear sway bar assembly. Now, let us apply what we have learned. Study this front suspension assembly and name as many components as you can. Follow each pointer carefully and take your time. Pause the video here if you need. Take a longer time as you want before reviewing the answer. Now compare your answer with the labels shown. Do not worry if you miss some components. The purpose is to strengthen recognition and help you connect each name with its location in the complete assembly. Now let us repeat the activity with the rear suspension. Name as many components as you can and think about the basic job of each one. Pause the video here before moving to the answer in the next slide. Here are the rear suspension components and their locations. Compare them with your answers, then trace how the springs, shock absorbers, control links, hub assemblies, and sway bar all connect through the rear subframe. That brings us to the end of lesson 007 on identifying suspension parts and components. Thank you for joining PrimeStar Automotive. I hope this lesson has helped you recognize the major components and understand where they are located. Continue learning, continue improving, and I look forward to seeing you in the next lesson. Subscribe to follow the Automotive Fundamental series. Thank you and good night.